What if I told you there was a secret code? A hidden language that explains nearly everything around us. It's a language that describes the swirl of a galaxy, the beat of a pop song, and the perfect curve of a thrown ball. This isn't science fiction. It's not a fantasy from a blockbuster film. This secret language is mathematics, and you already know more of it than you think. Forget the dusty chalkboards and the anxiety-inducing exams for a moment. Let's reframe what math truly is. It isn't just about homework or getting the right answer. It's about understanding the deep, elegant, and sometimes surprising patterns that govern our world. It's a tool for curiosity, a lens that helps us see the universe with breathtaking clarity. Think of it this way: math is the ultimate story of how. How does a tiny seed know how to grow into a magnificent tree? How does your phone send a message to someone on the other side of the planet in an instant? How do artists create works that feel perfectly balanced and beautiful? The answers to these questions, and so many more, are written in the language of numbers, shapes, and patterns. It's a story that has been unfolding for thousands of years, with each generation adding its own chapter. It's a story of logic, but also of incredible creativity and imagination. It's the framework upon which our reality is built, waiting for us to explore its structure. Many of us have a complicated relationship with math. We remember it as a rigid subject, a series of rules to be memorized without question. But that's like saying that learning the alphabet is the same as appreciating Shakespeare. The rules are just the starting point. The real magic happens when you start to use those rules to build, to explore, and to discover. What if we approached math not as a chore, but as an adventure, a quest to decipher the code of the cosmos? This isn't about becoming a world-class mathematician overnight. It's about opening your mind to a new way of seeing, a way that makes the ordinary extraordinary. Instead, we're going to peel back the curtain and reveal the simple, beautiful mathematics hiding in plain sight. We will look at the world as a mathematician might, with a sense of wonder and a desire to find the underlying logic. We will see that math isn't something to be feared. It's something to be celebrated. It's the most powerful tool we have for making sense of the universe and our place within it. So are you ready to learn the secret code? It's time to see the world with new eyes. For so many of us, our experience with mathematics is confined to the four walls of a classroom. We see it as a subject on a timetable, nestled between history and geography. It's a series of problems on a worksheet, a grade on a report card. But this view is incredibly limiting. It's like visiting a magnificent city but never leaving the train station. The real world of mathematics is vast, vibrant, and fascinating, extending far beyond any textbook. It's in the rhythm of the music you listen to, the architecture of the buildings you admire, and the technology you use every single day. Math is not just a school subject. It is a fundamental part of the human experience. Let's start with your daily decisions. When you follow a recipe to bake a cake, you are using mathematics. You measure ingredients in specific ratios. You set timers, and you adjust cooking temperatures. When you go shopping and compare prices, trying to figure out the best deal, you are performing mental calculations. You're using percentages for discounts and division to find the unit price. Even planning your route to work involves a type of math called optimization, finding the most efficient path to save time and fuel. Technology is another area where math operates silently in the background, performing miracles we take for granted. Every time you stream a movie, complex algorithms are at work. The GPS in your phone relies on the mathematics of trilateration, using signals from satellites to pinpoint your exact location on the globe. From the encryption that keeps your bank details safe online to the code that runs your favorite video game, math is the invisible engine powering our modern world. And what about art? Surely that's the domain of pure creativity, free from the rigid rules of logic. Not at all. Artists throughout history have used mathematical principles to create works of stunning beauty and harmony. The concept of the golden ratio has been used to create pleasing proportions in paintings, sculptures, and architecture for centuries. The intricate geometric patterns found in Islamic art are a breathtaking celebration of symmetry and tessellation. Even music is deeply mathematical. Math is not the opposite of creativity. It is one of its most powerful tools. If you want to find the most creative mathematician of all, look no further than nature itself. The natural world is a masterpiece of design, and its blueprints are written in the language of mathematics. You don't need a laboratory or a supercomputer to see it. You just need to step outside and pay attention. Look at the leaves on a plant. Notice how they are often arranged in a spiral pattern as they ascend the stem. This isn't random. This arrangement, called phyllotaxis, allows each leaf to get the maximum amount of sunlight without shading the ones below it. It's a perfect solution to an engineering problem, solved by evolution using a simple mathematical rule. Consider the humble honeycomb, a marvel of structural engineering. Why do bees build their homes with perfect hexagonal cells? For a long time, mathematicians suspected that the hexagon was the most efficient shape for tiling a surface, using the least amount of wax to store the most amount of honey. In 1999, Professor Thomas Hales provided a formal mathematical proof confirming that the bees had it right all along. They are intuitive geometers, creating a structure that is both strong and incredibly economical. The patterns don't stop there. Take a walk in a forest and look at the way trees branch. You'll see a pattern repeating itself. A main trunk splits into smaller branches, which in turn split into even smaller branches, and so on. This is a classic example of a fractal, a mathematical concept where a simple pattern is repeated at different scales. This branching structure is incredibly efficient for transporting nutrients from the roots to every single leaf. The same fractal patterns can be seen in the intricate network of rivers, the jagged shape of a coastline, and even the structure of our own lungs. And then there is one of the most famous number sequences of all, the Fibonacci sequence. It starts with 0 and 1, and each subsequent number is the sum of the two preceding ones. This sequence appears with surprising frequency in the natural world. The number of petals on many flowers is often a Fibonacci number. The seeds on a sunflower head are arranged in 2 sets of spirals, and the number of spirals in each direction are almost always consecutive Fibonacci numbers. This isn't a coincidence, it's a result of an efficient packing algorithm, guided by simple mathematical principles of growth. When we think of art and math, we often place them at opposite ends of a spectrum. Art is seen as expressive, intuitive, and emotional, while math is perceived as rigid, logical, and cold. But this is a false dichotomy. Throughout history, these two disciplines have been deeply intertwined, each one inspiring and enriching the other. Many of the world's greatest artists were also keen mathematicians, using principles of geometry, proportion, and perspective to create masterpieces that resonate with a sense of order and harmony. Math, in its purest form, is a creative pursuit, and art is often a visual representation of mathematical beauty. One of the most enduring connections between art and math is the golden ratio. This special number, often denoted by the Greek letter phi, has been hailed for centuries as the key to aesthetic perfection. It's found when a line is divided into 2 parts so that the ratio of the whole length to the longer part is the same as the ratio of the longer part to the shorter part. Artists like Leonardo da Vinci are believed to have used this ratio to compose works like the Mona Lisa and the Last Supper. The Parthenon in Athens also contains many proportions that approximate the golden ratio. Symmetry is another mathematical concept that is central to art. Whether it's the bilateral symmetry of a human face in a portrait or the radial symmetry of a beautiful rose window in a cathedral, our brains are hardwired to find symmetrical patterns appealing. The intricate tilework found in Islamic art and architecture, known as zellage, is a dazzling display of geometric genius. These complex patterns are created using a limited set of tile shapes that fit together perfectly without gaps or overlaps. These artists were master geometers, exploring complex mathematical ideas through their craft. But the connection goes deeper than just applying rules. The very act of creating art often involves a kind of mathematical thinking. An artist must think about space, form, and composition. A sculptor must understand how shapes interact in 3 dimensions. A musician composes with rhythm, harmony, and structure, which are all fundamentally mathematical concepts. The process of exploring patterns, relationships, and structures is common to both artists and mathematicians. They are both searching for elegance and truth. In this sense, a beautiful equation can be as profound as a beautiful painting. You might not realize it, but you carry a powerful mathematical device with you everywhere you go. Your smartphone is a testament to the incredible power of applied mathematics. It's not just a calculator. Its very existence is made possible by countless mathematical discoveries. Every time you make a call, your voice is converted into a string of numbers, a digital signal. This signal is then scrambled using complex mathematical codes, a process called encryption, to ensure your conversation remains private. This is the world of cryptography, a branch of math that protects our most sensitive information, from private messages to online banking transactions. Think about the photos you take with your phone. When you snap a picture, the camera's sensor captures light information, which is then processed by sophisticated algorithms. These mathematical recipes sharpen the image, correct the colors, and reduce any unwanted noise. When you send that photo to a friend, compression algorithms cleverly find and remove redundant information, making it much smaller and faster to send over the internet. Math is also a silent partner in your kitchen. Baking is a science and its language is math. A good recipe is essentially a mathematical formula. It specifies precise quantities and ratios of ingredients. If you want to bake a cake that is twice as big, you have to double every ingredient, maintaining the correct proportions to ensure the chemistry of the bake works correctly. Adjusting a recipe for a different number of people is a practical exercise in multiplication or division. Even the cooking time and temperature are variables in a scientific equation designed to produce a delicious result. Beyond the kitchen, math helps manage the logistics of your entire home. When you create a budget to track your income and expenses, you are using basic arithmetic to make informed financial decisions. When you decide to paint a room, you calculate the surface area of the walls to figure out how much paint you need to buy. If you're assembling flat-pack furniture, you're following instructions that rely on spatial reasoning and geometry. From managing your time effectively to understanding your utility bills, math provides the tools you need to bring order and efficiency to your daily life. It's the practical skill that helps your world run smoothly. Mathematics is not just about serious calculations and complex theories. It's also full of delightful surprises and clever tricks that can make numbers fun. These little secrets can spark a sense of wonder and show that math has a playful side. They reveal the elegant patterns that hide just beneath the surface of arithmetic. For instance, let's look at the simple magic of multiplying by 11. For any two-digit number, say 43, the trick is easy. You just add the two digits together, 4 plus 3 equals 7, and place that sum in the middle. So 11 times 43 is 473. It works almost every time, and honestly, it feels like a little bit of magic. Another fascinating pattern emerges when we explore the number 9. Have you ever noticed that when you multiply any number by 9, the digits of the answer always add up to 9 or a multiple of 9? Let's try it. 9 times 7 is 63, and 6 plus 3 equals 9. 9 times 12 is 108, and 1 plus 0 plus 8 equals 9. This intriguing property, known as casting out nines, has been used for centuries as a quick way to check the results of multiplication. Take the sum of consecutive odd numbers. The first odd number is 1. The sum of the first two, 1 plus 3, is 4. The sum of the first three, 1 plus 3 plus 5, is 9. The sum of the first four, 1 plus 3 plus 5 plus 7, is 16. Do you see the pattern? The answers are 1, 4, 9, 16, the square numbers. This beautiful relationship connects two seemingly different types of numbers. Discovering these tricks and patterns can fundamentally change your relationship with math. It transforms it from a subject of rote memorization into a playground for your mind. It encourages you to ask why and what if. Why does the multiplying by 11 trick work? What other number patterns can I find? This kind of curiosity is the very heart of mathematical thinking. It's not just about finding answers. It's about the joy of the discovery itself. These simple tricks are gateways, inviting you to step inside and explore the elegant and often surprising world of numbers. Some of the biggest ideas in mathematics began as deceptively simple concepts. Take the number 0. Today, we use it without a second thought, but its invention was a revolutionary moment in human history. For centuries, many great civilizations, including the ancient Romans, had no concept of 0 as a number. They had ways of indicating nothingness, but they didn't have a symbol that could be used in calculations. The idea of a number that represents nothing was a profound philosophical leap. It was the invention of zero as a placeholder that truly unlocked the power of our modern number system. Without zero, our system of place value would be impossible. The difference between 52, 502, and 5002 is all down to the humble zero. It allows us to write down very large or very small numbers with ease and clarity. But zero is more than just a placeholder. It's a number with its own unique and sometimes strange properties. Adding or subtracting zero changes nothing. Multiplying by zero always results in zero. But what about dividing by zero? This is where things get really interesting. Division by zero is undefined in mathematics because it leads to logical contradictions. It's a rule that shows even in a world of logic, there are boundaries and mysteries. Another simple idea with profound consequences is the concept of infinity. Like zero, infinity isn't just a very large number, it's a completely different kind of idea. It represents a process that never ends. Mathematicians have wrestled with the nature of infinity for centuries, discovering that there are different sizes of infinity. The number of whole numbers is infinite, but the number of points on a line is a larger, uncountable infinity. This mind-bending discovery by Georg Cantor in the late 19th century showed that even concepts we think are simple can have incredible depth and complexity. These foundational ideas, zero, infinity, the rules of arithmetic, are the building blocks upon which all of modern mathematics is constructed. They are like the simple rules of chess. By themselves, they are easy to learn. But from these simple rules emerge a game of breathtaking complexity and endless possibility. The journey from counting on our fingers to developing calculus or understanding the geometry of space-time is a story of how small, simple ideas can be combined and built upon to create intellectual structures of incredible power and beauty. It shows that the grandest discoveries often have the humblest beginnings. Every great technological achievement you see around you is built upon a foundation of small, interconnected mathematical ideas. It's a chain of discovery where one insight leads to another, eventually resulting in something extraordinary that can change the world. Think about the magnificent bridges that span vast rivers and valleys. The engineers who design these structures rely on the principles of geometry and physics, all expressed through the language of mathematics. They use equations to calculate the forces of tension and compression, ensuring that every beam and cable can withstand the weight of traffic and the power of the wind. The computer or phone you are using to read this is another perfect example. Its journey began with a very simple idea from the 19th century by a mathematician named George Boole. He developed a system of logic now called Boolean algebra, where everything could be represented as either true or false, 1 or 0. At the time, it seemed like an abstract curiosity. But a century later, this simple binary system became the fundamental language of digital computers. Every complex operation your computer performs is broken down into millions of simple calculations using just ones and zeros. A small logical idea grew into the digital revolution. This process of building big discoveries from small ideas is at the heart of scientific progress. When scientists first started encoding information for telegraphs and early telephones, they faced a problem: how to send messages accurately, even if there was noise or interference on the line. This led to the development of error-correcting codes. These are clever mathematical schemes that add extra, redundant information to a message. If part of the message gets corrupted during transmission, the mathematical structure of the code allows the receiver to detect the error and, in many cases, correct it automatically. This small idea is now crucial for everything from deep space communication with satellites to the reliability of your Wi-Fi network. The story of mathematics is a story of cumulative knowledge. Isaac Newton famously said, "If I have seen further, it is by standing on the shoulders of giants." Every new discovery, no matter how revolutionary it seems, is built upon the work that came before it. The calculus developed by Newton and Leibniz, which is essential for modern physics and engineering, was built upon centuries of work in algebra and geometry. The complex algorithms that power artificial intelligence today are built upon foundational ideas in statistics, probability, and linear algebra. Small, patient steps of logic, taken by countless individuals over generations, lead to giant leaps for humankind. We have journeyed from the classroom to the cosmos, from the patterns in a flower to the code in your phone. We have seen that mathematics is not a dusty, forgotten subject. It is a living, breathing language that describes the world around us. It is the secret code that unlocks the mysteries of nature, the blueprint for art and technology, and the silent partner in our daily lives. The story of math is the story of human curiosity, our innate desire to find patterns, make connections, and understand the universe on a deeper level. It is a story that is still being written, with new discoveries being made every day. You do not need to be a professional mathematician to appreciate this story. You just need to be curious. The next time you see a spider's web glistening with morning dew, take a moment to admire its geometric perfection. When you listen to your favorite song, try to tap out its rhythm and notice the repeating patterns. When you are cooking, think about the ratios and proportions that make the dish work. By paying attention, you can start to see the hidden mathematical layer that underpins so much of your experience. The world becomes a richer, more interesting place. This is your invitation. An invitation to look for the math secrets that are hiding in plain sight. Start asking questions. Why are manhole covers round? A round cover can't fall through its own opening. Why do bubbles form spheres? A sphere is the shape that encloses the most volume with the least surface area. These questions are the starting point of every great mathematical adventure. They transform you from a passive observer into an active explorer. You begin to see the world not as a series of random events, but as an intricate and elegant system governed by logical principles. So I encourage you to see the world with new eyes. Let go of any lingering fear of numbers and embrace the joy of discovery. See the geometry in a snowflake, the algebra in a financial plan, and the algorithms in a board game. Math is not just for geniuses, it is for everyone. It is a powerful tool for thinking, a beautiful language for describing reality, and a source of endless wonder. The world is full of mathematical puzzles waiting to be solved and beautiful patterns waiting to be admired. All you have to do is look.